All right, so obviously the spoil board has been put into place here and we're basically ready to start cutting the spoil board. And I did want to talk a little bit about what I have here. So I have 2 layers of MDF, you saw that already being glued up, but then flanked on either side is these filler pieces, which are 6 inches in width, and the center section is 49 inches in width, and then they go all the way to the end. I don't have access to large enough sheet goods to cover the entire bed in one go, so I'm doing it in several pieces. And below those, I actually have a piece of hardboard. It's like a 1/4 of an inch-ish. It's basically going to be a sacrificial piece that I can cut all the way through this material and into and not worry about hitting the aluminum below it. That will be removed after the first few tool paths are done, but that's the setup. But I did want to say quickly that you will probably notice that I have a spoil board looking piece off to the side over there, and that's because admittedly I will not be doing this for the first time. I off camera tested out a lot of stuff on a practice spoil board, which is always recommended and usually something I would show on camera, but I decided this time to keep it off camera because, as I'm sure you can imagine, both filming something new and worrying about doing that something correctly is very difficult. And in this instance, I decided I wasn't going to film it. I was going to learn as much as I could using that test spoil board and then share with you guys that information and my secondary process of going through this. So we're about ready to start here. Now, I also printed out this large to-do list for myself because we're going to be doing somewhere in the neighborhood of 10 or so tool paths with at least 3 different tools in order to create the spoil board. And being as how this is more or less my first time doing it, I decided to write everything down as I was modeling it and putting it into CAD so that now a few days later when I'm actually doing it, I remember how this is actually supposed to go and in what order. So I recommend doing something like that. So we're going to get started with the very first process, which is going to be creating the mounting holes so that we can get this mounted down and really start cutting in all of our pieces. So let's roll a montage and get this thing set up for that first cut. So I'm going to quickly go through the tool paths and why I chose what I did, because this is very interesting to me and I think you might find it interesting too. So first of all, come with me. This section here, this first main pocket is the first tool path, and then the bottom slot is another tool path. Now technically this was done in 3 tool paths and I'll show you why. So traditionally that would be called a pocket. Okay, and a bit would come in just like this one, and it would come in and it would go around, and then it would go inwards and go around, and then go inwards and go around, and clear the entire pocket out. So basically it would make a bunch of passes with the diameter of the circle getting smaller and smaller and smaller. What that means in an instance like this is that this bit can reach its maximum speed out here, but as it gets closer in, the amount of room it has to travel, the distance it has to travel, is much less, meaning the bit actually can't even get up to the correct speed. And so this is a way that most people would do a pocket like this, And it is perfectly viable, but it actually takes longer and produces less. I'm gonna try to be simplified here. It creates not as good of chips because your feeds and speeds get messed up as the circle gets smaller and smaller. So instead, a better way to do it, let me rephrase that. Another way to do it would be a profile cut. And in this instance, I'm using 2 profile cuts. So this outer circle represents the size of our pocket we want to make. And I'm doing a profile cut on the inside of the line, which means that the bit follows the inside edge of that line all the way around. Now this bit isn't perfectly to size and this is a little oversized, but the way this works is it goes around one time, okay? And normally it would go around one time and then step down. But I have what's called a spiral tool path in there. Instead of the bit going around and then going down, going around and going down, it actually goes like this. If that makes sense? So it goes down and around all at the same time, which is also an efficiency boost. So it goes and cuts all the way down. First, actually, it cuts on the inside of the smaller circle all the way down to our finished depth. And then on a second tool path, it cuts on the inside of this outer line all the way down to the finished depth. And because the bit and these circles are sized appropriately, it clears the whole thing out without having to do a bunch of passes individually and a bunch of step overs and stuff like that. Does that make sense? Mm-hmm. Okay. I'm trying. I may sound like I know what I'm talking about, but this is what I'm learning this as I go. So this is all really cool stuff to me. So yeah, this was done in 2 profile cuts. Now similarly, Similarly. All right, whatever. The slot at the bottom is represented by this. And people also would, I myself, before I learned this, would select pocket for that, right? It makes sense. This is gonna come in there and it's gonna start here and it's gonna go around and make that. But another way you can do it is that if the slot you're making, if you have a bit the same size as the slot, in this case it's 3/8 of an inch, I just use a 3/8 inch bit and I put it to follow this line I've created here. It just plunges down and then follows the line. So instead of going around the bunch, it just goes down and over. So it's a big efficiency gain there. So again, this is using profiles instead of pockets to boost your efficiency when possible. And because the bit is already round, it creates the round part at the end. Pretty clever, huh? So now we have those done. Our first set done, so we're going to remove all of this and attach the spoil board to the actual table. All right, here's something a little new. Well, this will be a first for me. Putting a Sharpie in the spindle. And this is so that I can mark the location to put all these T-nuts. So we have to align all these like kind of perfectly before we put the table back on, and that sounds difficult, so we're going to see if we can't mark the location using the file we already have. All right, fingers crossed. Everything is mounted. That went fairly well. It was pretty darn easy. I only had one of the T-nuts end up kind of going squirrely on me, and I had to kind of adjust it and get it back right, but thankfully I didn't have to take anything off. So everything is mounted down, and I started too late in the day because now it's time for dinner, and the next few steps require kind of things to go back to back to back. So instead of kind of rushing things, I'm gonna put this off till tomorrow. So we'll see you in just a few seconds. And we're back. So now we're getting ready to cut the dog holes that are gonna be kind of flanking the T-track. I'm cutting them in 2 separate passes because I don't have a bit that's long enough to go through all 3 layers once they're glued up. So right now we're about to cut through just these 2 layers, and then in the very end we'll cut through 1 last layer to make them go all the way through the table. So I have a 1/2 inch upcut end mill in here. Upcut is probably not the most preferred. I'd rather have a down cut, but it's the only one that I have that's got a long enough cut in here. It just means that it'll be a little fuzzy on the top. That's the only downside of it, but that'll be cleaned up on our next pass. So let's get to it. All right, brother. So we just got finished cutting the T-track slots. We did that with a 1/2 inch bit at basically full depth in 1 pass. So I was able to hog that out pretty quickly, but it created a lot of dust, so I wasn't gonna talk through it. We had our masks on, but now you can see how this T-track is gonna fit in here. This T-track actually is gonna have to be cut into individual pieces, but as you can see, it is very snug and exactly the right height. So if I grab a straight edge like this, you can see that I'm not coming in contact. And actually this is supposed to be 2 thou inset for that reason. So I'm not coming in contact with the T-track, which is really important. So I have to cut a bunch of this T-track up, and then we'll put it in, and then the next step is gonna be gluing a 3rd sheet on. And we're actually gonna be gluing it on over the top of this T-track, which is very nerve-wracking, and then cutting in slots just barely to the edge of the T-track and stopping. It's going to be kind of intense, but it's going to demonstrate the capability of having a pretty awesome machine like this. But it's been a lot of fun watching it just zip through doing this, just because doing that by hand would be a nightmare, and just seeing how incredibly accurate this is, I mean, it's a perfect fit. I'm gonna get to cutting these up, and then we'll get to install them and put the last sheet on. Exciting. Well guys, I made a relatively big mistake that is fixable, and I want to show you what that is now. So unfortunately, these grooves that go in the Y direction are all off-centered, and the dog holes are all off-centered. Now the dog holes don't really matter. If I was to cut them correctly, it wouldn't matter because the hole just needs to go all the way through, and the next layer of the dog hole will be in the correct location and all as well. But these guys, they kind of need to be correct so that the T-track fits in them properly. So if I oversize them, it's not going to work as well. So I've got a plan and a solution, but I want to tell you why this happened so you can kind of understand it, because it was just a very minor oversight on my part caused this issue. To give you an illustration of why this happened specifically to mine and why it wouldn't happen to a lot of other people's machines, is because I've decided to run my machine in a somewhat unique way, in that I am not it all referencing the corner of any material, I am referencing the 0 point of the machine, meaning this front left corner. So the machine goes to 0, and then I know in software that, say, this piece of material is at 12 inches in the Y direction and 12 inches in the X direction, which is a different way of approach. The normal, more common approach would be you take your corner finder here, you place your material that you want to cut down, and you put your corner finder on there, and then the machine creates a 0 point right here at the corner of this material. And then it knows this is 0, 0, and it knows that that's the center because that's 0, 0. But because I'm doing it the way that I am, 0, 0 is off here in some arbitrary location. And what that means is that even though the footprint is fixed of the machine, it actually travels a little bit over that footprint. So whereas my table is 61 inches, there's maybe 61.2 something of actual travel in the machine, and I didn't account for that in the X direction. I did account for it in the Y direction, and it just totally slipped my mind in the X direction. So I hope I'm making sense. I really am, because this is hard for me to wrap my head around too. So clearly we're doing something very unorthodox here. We are about to fully encapsulate this T-track inside of the table, and then we're going to come back and cut the slots out of the top, and I'll show you why later, specifically while we're doing that. But I kind of jumped ahead of myself, and I didn't really talk about this T-track being installed, and I wanted to do it now while I'm doing this glue up, because obviously I won't be able to show you that. So, because with the glue up, I'm trying to keep everything as wet as possible so that I don't get any dry spots. As you can see, I have a bunch of these slots here, these gaps, and those gaps are going to allow us to be able to drop T-track accessories and bolts and whatever else that we're using, hold downs, down into the table at multiple locations. So that's what that's for. And as far as this glue up goes, I'm just trying hard not to get a lot down in the slots, because obviously that's going to be a pain in the butt to deal with later. So yeah, a lot going on. This is kind of complex. I need to get where you are, and we're just going for it. I did do a very small test version of this, and it worked pretty darn well. So this is definitely risky. Sometimes you got to risk it for the biscuit. The main advantage of doing this the way that I'm doing it is the T-track is going to be, like I said, fully encapsulated, which means that it won't be able to be pulled up at all. You'll notice that I didn't use any form of fasteners other than a little bit of CA glue to install the T-track, and that's because really the only movement I'm worried about is it sliding around, not actually pulling out, which is the normal movement you'd be concerned about with T-track. But I don't have to worry about that because it's going to be, like I said, encapsulated. But I'm doing it kind of in a unique way that I'm letting the machine cut it out with the T-track already inside. I'm removing a handful of steps, and I'm doing that for, again, reasons that'll make sense, I guess, more later. I should have really thought about talking about this more before doing this, but I got a plan. Got some down in there a little bit, but it's not the end of the world if I do get some in the T-track, because it will just break out. It doesn't stick well to the glue doesn't stick well to it. I guess the most important thing here is to make sure that every bit is wet. You can see sections kind of kicking off over there where I started, and I don't want to have any dry sections, so I'm gonna have to kind of run back over there and hit that with a little bit of extra glue. All right, next day, this is fully set up and cured, so we're ready to cut the slots. Now, just to give you kind of a visual of what we're attempting to do, this is a 1/4 inch end mill, and we're gonna be plunging down and cutting a 3/8 inch slot, which is the width of this measurement. But what that's gonna do is it's gonna leave this top layer overhanging the T-track, and that's what's gonna allow this T-track to stay in place and not be pulled up when you pull fasteners into it. There are certain types of T-track that are a lot more expensive that bolt down, and Jay Bates actually used that on his machine, and that stuff looks incredible, but it's quite expensive. So I thought I would try this out. You know, I think this is gonna work pretty well. This stuff is like a fraction of the price, so if it doesn't, it's not the end of the world. So anyway, we're gonna come down. Are you good, ma'am? Are you okay? You're whining. What's wrong? What's wrong? What's wrong? What's wrong? Huh? Am I not talking to you? Is that the problem? Is that the problem? I'm sorry. I'm sorry I'm not talking to you. So what we're doing, we are going to come down and we're going to create a pocket. But the tricky thing here is that we need to cut all the way through this material, but not touch the T-track for obvious reasons. Now, normally what you would do, and what we've done so far every time, is we've taken our touch-off plate, we've come down and touched here, and that tells the machine exactly where the material surface is. So it knows, you know, this is 0 right here. This is the top of the material. The problem with doing it that way is that materials vary in thickness, and especially when you laminate things, they can be different thicknesses based on where you put this. And we need to be accurate within a thou or so that we don't hit this T-track. So how do you do that? Well, there's a clever way of doing it, which is actually zeroing to the bottom of this layer. And in order to do that, we could have left the machine on zeroed before we glued this up, but I actually left this piece cut out back here on the back of the machine, and this will stay cut out forever. It doesn't really affect our ability to use the machine, but this is the second layer, which means that we can always reference the second layer's height if we need to. Things that we might need to do that for is if we ever want to remove the T-track or want to cut in new stuff but not hit the T-track, that kind of thing. This allows us to be able to simply do that. And so the way that that works is this is the 0. You now tell the machine that the material is 3/4 of an inch thick, but it doesn't matter if it's 3/4 of an inch thick or not, because it's just going to cut down to that 0 mark and stop perfectly there, or at least in theory. So we're going to Z to this and then set our 0 to the bottom of the material instead of the top, and we're going to run our slots in, and this is where kind of the magic's going to happen of this whole spoil board. Fingers crossed. Well guys, that's all we have time for this week. We actually next week are going to be working on the vertical table that's going to go right up here on the front, and we'll be working on creating some clamps just like this one. This one is actually a failed attempt, but it's the only one I have to show you right now. This is the idea behind the T-track. I'm going to be able to put these in at whatever location essentially I want in the table, and they ride in these slots, which gives me reference points within software, and also gives me a reference point that is followed by a clamping surface that can clamp 2 pieces at a time. In the instance I want to do, say, 2 table legs or something along those lines. These clamps will work in every direction, including the end, which is kind of neat. So just to give you a quick example of how strong these are, that just got tight. So if I just do like a quarter of a turn, okay, okay, it came out, but I pulled my full body weight on that. And yeah, they're crazy strong, even with just one on there. If I go a little tighter than that, I will not pull it out. It's insane. And that's just with one clamp. So obviously there will be more clamps on there, but this is going to give us the ability to do some really cool things with aligning parts and pieces. You know, obviously it can be clamped that way, you know, the corner can be clamped there, and it's just a really cool system that I think is going to be a cool addition to this. So thanks for following along with this project. I know this video was super long. If you have any interest in seeing something specific, please leave a comment down below and I'll try to add some more content into next week's video. Hope you guys are enjoying this, and yeah, we'll see you next week.